can we convert the number 3201 in base 6 into base 10? Notice it'd be a bad idea to call this number 3201 because the 3 is not worth 1,000 and the 2 is not worth 100. Excuse me. So, what are they worth? Well, in base 6, instead of 10 to the 0 power, we have 6 to the 0 power. Instead of 10 to the first power, the tens place, we have 6 to the first. Instead of the hundreds place, 10 to the second power, we have 6 to the second power, and here we have 6 to the third power. So this is the ones place, the sixes place, the 36s place, and 6 times 36 is 216, so these are the 216s place. So this is not 3,000, it's 3 of the 216s, plus this is not 200, it's 2 of the 36s, plus 0 sixes, plus 1 1. 3 times 216 is 648. 2 times 36 is 72. That's 0. That's 1. This 648 plus 72 would be 720. Plus 1 is 721. So I believe that if we take this number 3201 and write it in base 10, it's 721. Now the question is, how could we go back? So we figured out how to do this kind of problem. We simply write down what each of these digits is worth, and then we do all the arithmetic, probably with the aid of a calculator. Now, how do you go from base 10 back to base 6? Well, we know that this should be 3201 base 6, but how do we figure that out? Well, we make a little template. We can go as far as we want. This will be 6 to the 0, 6 to the first, 6 to the second, 6 to the third. If we did 6 to the fourth, it would be this times 6, which would be, I think, 1296. Are we going to need any of these 1296s to make 721? And the answer is no, because 1296 is bigger than 721. So we're going to need some 216s, we're going to need some 36s, some 6s, and some 1s. And we can only use the digits 0 through 5 in base 6. So we can only put a 0 through 5 here, 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 and here. So one way to do this, a kind of plain way, is to just start taking away 216s. You can do this with a calculator, it's a little bit faster. But when we take away 216, we get 505. When we take away 216 again, we get 289. When we take away 216 again, we get 73. So we got 3 of those 216s out of there. And when we take away a 36, we get 37. When we take away a 36, we get 1. And so it takes a couple of 36s and 1 1 and 0 6s. So the strategy is just to take away as many of the biggest things as you can, and then when you're done taking those away, take as many of the next biggest things as you can. And all of this subtraction could be done very easily on a calculator, and it's okay to use a calculator for that purpose. And if you're very, very clever, you might get away with doing some divisions, but you got to be very careful because your remainders have to be handled correctly. So let's look at something else. 721, and we want to turn it into base 6. There is an alternative method. It's a little hard to understand why it works, but it works like a charm. And that is, if you want to turn a base 10 number into another base, then start dividing by the base you want to turn this number into, keeping very careful track of all remainders. So 6 goes into 7 once with a remainder of 1. It goes in twice. So 6 goes into 721 121 times with a remainder of 1. 6 goes into this 20 times with a remainder of 0. 6 goes into this 3 times with a remainder of 2. 6 goes into this 0 times with a remainder of 3. And if you read this remainder column from top towards bottom, you will get 3, 2, 0, 1. And if we scroll up here, that's exactly the base 6 number for 721. So if we divided by a series of 5s instead of 6s, we would have turned 721 into a base 5 number. And this is a pretty compact thing and a pretty useful thing, and it's described more fully in V7. I'd like to do a couple examples with base 16. The reason I think base 16 is important is it's used in a lot of computer applications behind the scenes. So if you go into a computer field, there's a fair chance that you will end up seeing base 16 sometime in your life. And the first thing to know about base 16 is that you need 16 different kinds of numerals, 0 through one that means 15. So you need numerals for all of these. Well, the numerals up to 9 are just the same. But then you need a single thing that means 10. And that's A, and a single thing that means 11, and that's B. So these are the base 16 numerals and what they equal. And so in base 16 we have that this will be 16 to the 0 power, 16 to the first power, 16 to the second power. This is the 1's place, this is the 16's place. I think this is 256. So we have B of these 256's, but what is B? B is 11. So we have 11 of these 256's, plus we have 2 of these 16's, plus we have A of these 1's, but what is A? A is 10, so we have 10 of these 1's. 256 times 11. Is 2,816, and this is 32, and this is 10, so that's 42, so I think I'm getting 2858. So I think that this number in base 16 equals 258 in base 10. How can I check that? Well, let's try doing the staircase thing on 258. When we're turning a base 10 number into another base, we can divide by that base. So we're turning it into base 16. Let's try dividing by the base. 16 will go into this once. That'll give me 9, so that's a 98. 16 will go into that 6 times, and there will be a remainder of 2. So I copied this down wrong. I copied this number down wrong. So I think that B2A in base 16 is 2858 and base 10 or 2,858. So now 2,858, and it's going to be a little bit hard to divide that by 16, but I'm going to try and see what we get. So you could do this on a calculator if you wanted to, but I'm going to see what happens here. I've got a 1 and maybe a 7. And maybe an 8. So I think this goes in 178 times, and I've got a 128, so that's remainder of 10. Now, how do I write that remainder of 10 using base 16 stuff? Well, I think it would have to be A being 10. And now 16 goes into this, and I think I can maybe do this one in my head. There's a remainder of 2. 16 goes into this 0 times, and there's a remainder of 11, but 11 is B. And there I have it, B2A, B2A. So back and forth, you can turn a base 16 number into base 10 by just doing expanded notation in base 16 and doing the arithmetic. To go backwards, perhaps the simplest way is to do one of these remainder or staircases carefully, and sometimes you need to do the divisions on the side.